The power factor meter. Welcome to our presentation on the power factor meter, a vital instrument in maintaining the health and efficiency of any AC electrical system. We'll explore how this device acts as a guardian of electrical efficiency in industrial settings. Defining power factor. The power factor, or PF, is a critical metric. It's the ratio of real power, the useful work done, symbolized by P, to apparent power, the total power supplied, symbolized by S. A PF value close to 1.0 is the goal, signifying maximum efficiency and utilization of electricity. Purpose of the meter. The power factor meter's primary purpose is to provide a swift, direct, and instantaneous measurement of system efficiency. This single instrument eliminates manual calculation errors and allows for crucial real-time monitoring, which is essential when dealing with dynamic electrical loads. The power triangle. To understand PF, we look at the power triangle. Real power, measured in watts, is the energy converted into useful work. Conversely, reactive power, measured in var, is the non-productive power oscillating back and forth due to inductive or capacitive components. Types of PF meters. Power factor can be measured using various instruments. Historically, the most common analog types were the electrodynamometer and moving iron meters. However, modern industrial environments now frequently utilize highly precise digital meters, often integrated into multifunction meters. Electrodynamometer principle. The classic electrodynamometer meter operates using fixed coils carrying the load current and two crossed moving coils forming the pressure circuit. These moving coils are intentionally designed with different impedances, one resistive and one inductive, to create the necessary phase split for measurement. Crossed coil mechanism. The key to the electrodynamometer is its unique mechanism. The two moving coils are rigidly fixed at a 90-degree angle, and crucially, there is no controlling spring. The equilibrium position of the pointer is dictated solely by the magnetic forces, which simplifies the design. Developing torque. Torque is produced by the magnetic interaction between the main current's fixed coil field and the fields of the two moving coils. Because the currents in the moving coils are phase shifted by approximately 90 degrees, they generate opposing torques that accurately reflect the system's overall phase angle. Reading the scale. The pointer comes to rest precisely where the opposing torques are equal, providing a direct readout proportional to the phase angle, or the power factor. A deflection to the left indicates a lagging PF due to common inductive loads, while a deflection to the right shows a leading PF from capacitive loads. Industrial optimization. In industrial settings, continuous PF monitoring is vital. Large inductive loads, such as heavy machinery, can often depress the power factor to 0.80 or lower, which typically incurs utility penalties. Implementing correction capacitors is the key strategy to raise the power factor, ideally above 0.95. Key takeaways. Summary. In summary, the power factor meter is an indispensable tool that instantly quantifies electrical efficiency. Its mechanism directly measures the phase angle, providing crucial data for identifying inefficiency and sizing correction capacitors to optimize industrial systems and avoid unnecessary costs. Questions. Q&A. Thank you for joining this overview of power factor measurement and the role of the power factor meter. I'm now open to any questions you might have regarding the instruments, their mechanism, or their industrial application.